So this time on this video, I'm going to demonstrate graphing a cosine function. I've already demonstrated on a prior video how to graph a sine function. So this time we'll do a cosine function, kind of balance it out a little bit so you can kind of see a variety. I did want to still graph something that contained transformations so that we can see that difference in a standard cosine graph. So as you recall before, if you viewed the other video, but if not, what I always like to do first is in graphing my function, which is f of x equals 1 plus cosine of 2 times x on the interval from 0 to 2 pi, I like to always know first and foremost what is the period of the function I'm getting ready to graph. I want to know how often will this graph repeat in its shape. So if we recall, that formula to figure out the period is 2 pi over c. Remember, 2 pi is the standard period for any sine or cosine graph. In this function, I notice c is the coefficient in front of x. That is 2. So this means that 2 pi over 2 will give me a period of pi. So this isn't going to be a standard 2 pi period for this graph. This is actually going to be a little bit shorter by a half, if you will. Half, it will repeat every pi units. So that tells me a little bit transformation language wise that this is going to dilate by a factor of a half with respect to the y-axis, if you will, because it's going to compress horizontally. As I said, a normal period is 2 pi. This is going to happen every pi unit. So this graph has been compressed horizontally, which is a dilation. So now that we have that period, let's determine some points for x. Again, I always like to begin at 0 and end at the period of the function. Now I'm going to find angles, and I'm going to get a total of 5 points. Again, I always like 5 points on my graph. That balances it out very good. At least 5 points for a full period works. I want to get some more points for x. So the way I like to do it is I like to find the midpoint between the two angles I'm currently looking at, which is 0 and pi. So basically the angle directly in the middle of that. And I can kind of look at my x-axis on my grid here to the left and see that it's right at pi over 2. Then I'll keep doing that process basically. I find the angle right in the middle of 0 and pi over 2. Now if we're looking at a unit circle, I could tell on a unit circle where 0 is and where pi over 2 is. And the angle that sits right in the middle of those two angles on the unit circle lies at pi over 4. Again, one more time. If you take find the midpoint between pi over 2 and pi, again on the unit circle, the angle that sits right in the middle of those two, you will see is at 3 pi over 4. Okay, and so those would be the 5 angles that I'm going to graph on my grid here. So the next step, now that we have them, let's evaluate for f of x. Let's find the answers. So here's what this means. This means that the first thing you have to do is you have to multiply these excuse me, you have to multiply these angles times 2 before you evaluate the cosine of the new angle. After you do that, then you add 1. Okay, so let's set up how this is going to look. Let's see if we can do this. So I'll use parentheses here. That's a raised dot there. Not the best, but we make it work. So here's what I want you to discover as I evaluate each of these. When I multiply 2 times the angles for x that I found and using here, I'm going to notice something I'm going to come back to in all 5 of these angles. You're going to notice, and I'll give it away early, that you're going to come back to your quadrantal angles, right? And you'll know what I'm talking about, hopefully, when I say quadrantal angles. 2 times 0 is 0, which means now you're looking for the cosine of 0, which is 1. 1 plus 1 is 2. Okay. 2 times pi over 4 is pi over 2. Now you're looking for the cosine of pi over 2, which is 0. And 1 plus 0 is 1. 2 times pi over 2 is pi. The cosine of pi is negative 1. 1 minus 1, or 1 plus negative 1, is 0. 2 times 3 pi over 4 is 3 pi over 2. The cosine of 3 pi over 2 is 0. Excuse me. Yes, it's 0. Plus 1 is 1. And then 2 times pi is 2 pi. Of course, cosine of that is 1. 1 plus 1 is 2. Now, as I look at my function, how is it different from a standard cosine graph? Well, there's 2 key features. I notice number 1, my period changed. My period is not 2 pi, it's pi. I also notice that I'm adding 1 on the end, which means there's a midline. Okay, so with that, let's draw the midline. Again, I always like to have it. Always a good practice. Draw your midline on your graph. Now we're going to plot the points. Let's see if we can find a more productive way to do this. Alright, so we're going to plot 0, 2. Pi over 4 is right in the middle here, remember? Then pi over 2. And then 3 pi over 4. And then pi. Now remember, we're supposed to, according to the directions, graph this on the interval from 0 to 2 pi. This just takes us to pi, remember? So we need to sketch another rotation. So that means the next point after pi, if I'm following the cycle and the pattern, would belong right here. Okay. Technically that would be at 5 pi over 4 in quadrant 3. Then at 3 pi over 2, I would be at 0. The next angle would be in the middle here. That would technically be at 7 pi over 4 in quadrant 4. And then, of course, you end at 2 pi. So if you connect these points, you'll see, hopefully, the shape of a cosine graph that starts at a maximum and ends at a maximum. I'll take out the extra stuff that I added in here. And there you go. There's your cosine graph. And that's how you would graph it with transformations.